Welcome. We're going to do a little matrix multiplication. We have two matrices here. The first one has the entries 3, 0, 1, 2, 1, and 3. The second matrix has the entries 4, 1, 2, 3, 1, 2. Now, each matrix has a number of rows. Rows are horizontal. Notice this first matrix has two rows, row 1 and row 2, and columns go vertically. And notice this first matrix has three columns. There's column 1, there is column number 2, and the third column is right out here. So two rows and three columns for that first matrix. The second matrix has three rows. Here's the first row. Remember, they're horizontal. There's row 1, there is row 2, and finally row 3. But it only has two columns. Column 1, and they're vertical. Column 1 and column 2. Now, matrix or matrices have dimensions. Matrices, if you haven't figured out, is plural of matrix. They have dimensions, and dimensions are the number of rows they have by, and we use an X for the word by, the number of columns. So number of rows by the number of columns. So our first matrix has two rows and it has three columns, so it is a 2 by 3 matrix. Our second matrix over here has three rows and it has two columns, so it is a 3 by 2 matrix. And we can multiply matrices if let me just label rows and columns for the second matrix. We can multiply matrices if the number of columns in the first matrix is the same as the number of rows in the second matrix. So in this case they are the same, 3 and 3. We have the same number of rows and same number of columns. But I have another pair of matrices out here, and notice this first one has two rows and three columns. It's a 2 by 3. And the second matrix has also two rows and three columns. And notice that they do not match up. There are three columns in the first and two rows in the second. We cannot multiply that second pair of matrices. We cannot multiply if the number of rows and the number of columns doesn't match. But we can multiply our first matrix, two matrices, pair of matrices, and so we can do that, and our result will be the number of rows in the first matrix by the number of columns in the second matrix. So our product will be a 2 by 2 matrix. 2 by 2 matrix for our product. Now we're going to need a lot of room to do this, so I've erased a bunch of things. And now let's get ready to write our product. And so I'm going to make a large matrix because I want to show a lot of work on this the first time we go through it. And remember, our product is going to end up being a 2 by 2 matrix. And so let's kind of delineate between the rows. And so we'll have two rows, and this is just a line between them. And so we'll have row 1 on the top and row 2 on the bottom. Typically you wouldn't put lines inside of your matrix like this, but I want to kind of divide them up and show where the rows and columns are. And we said we're going to have two columns, so there's column 1 and column 2. It's a 2 by 2 matrix. And now let's actually find what are the entries that go in each of these. So, for example, in row 1 and column 1, what goes in there? Well, we have to take the first row of our first matrix and the first column of what we're multiplying it by of the second matrix, and those are the two, that row and that column get multiplied together. And here's how. We take the first entry of row 1 and we multiply it by the first entry in column 1. So we're going to multiply 3 times 4 in this case. And then we take the second entry in row 1 and multiply it by the second entry in column 1, and we add that product. So we're going to add 0 times 2. And then finally, we're going to multiply the third entry, which is 1 in this case, times the third entry in the column. So that will be 1 times 1, and we add all those three together. And then we'll do the multiplication first. We'll get 12 plus 0 plus 2, 1 rather, plus 1. And they all add together to give us 13. And that will be the entry in our product matrix in row 1, column 1. Now typically you do row 1, column 2 next, but you don't have to. And so for a little change of pace, let's do row 2, column 2. So for row 2, column 2, we have to pick row 1 from our first matrix and multiply it times column 2 in the second matrix. And once again, piece by piece, entry by entry. So we're going to multiply that first entry, which is a 2, times the first entry in that column, which is a 1. So 2 times 1, and add to that the product of the second entry, which is a 1, times the second entry in that column, 1 times 3. And finally, we're doing row 2, column 2. We're going to take the third entry in row 2 and multiply it times the third entry in column 2 of the second matrix, and multiply and add those together. 2 times 1 is 2, 1 times 3 is 3. What's 3 times 2? That's 6. And add those together and we get 11. Okay, now let's finish this off. We still haven't done row 1, column 2, so that means we're going to have to use the first row and the second column. So that would be 3 times 1, which is 3, 0 times plus 0 times 3, which is 0, plus 1 times 2, which is 2, and those all add up to 5. I'm rushing through these. And let's do row 2, column 1. So row 2 and column 1, that would be 2 times 4 is 8, and then plus 1 times 2 is, and I hope you're seeing where I'm getting all these values. 1 times 2 is 2, plus 3 times 1 is 3. Add those together and we get 13 for that entry. Now in real life it looks more like this. We'd be multiplying the first row times the first column, and that would be 13 after we've added those all together. And then first row, second column, we would do that. We get a 5 there. Second row, first column, when you multiply and add those together, 8, 10, 13 will go into the second row, first column, and second row, third column, 2 times 1, 1 times 3, and 3 times 2. Add those together and we get 11. So that's what it looks like in real time. Hope that helps. Bye.